Okay, hey, here we're going to have find the inverse of this exponential function. Its characteristics. First off, we have this table right here. And here's the thing about inverses. Basically, the x and y's kind of change places. So let's look at what we have first. First off, if the asymptote is y equals -2, well, the asymptote on the logarithm will then be x equals -2. All right. Well, if the x-intercept is at 0.630, well, then the y-intercept will be 0.63. They just trade places. So if the y-intercept is 0, -1, the x-intercept will be -1, 0. But here's now if it had been a domain question, it would be x greater than -2, but it says range. So here the range is just a set of all real numbers. All right, but if it had been domain, it would have been x greater than -2. Basically, x and y is trade places on an inverse. All right. So to find the inverse, remember you trade places with the x and y. Then you solve for y, which basically means I would -3 from each side. So I would get this x minus 3 equals 5y. And how do you get an exponent, a variable out of the exponent? Well, if it's a base 5, you use log base 5. So I'm going to use, if I do it to one side, I've got to do it to the other. That will basically cancel those out. So y is equal to log of base 5 to the quantity x minus 3. That's our inverse of y equals 5x plus 3. Notice you have a plus, a minus, an exponent, a log. They're inverses. So how do you graph the inverse? Well, basically the points trade places. Across that symmetrical line of y equals x. So you have a point at 0, 3, so I got to have one at 3, 0. And you have a horizontal asymptote at the y equals 0, so I have to have one at x equals 0. And basically your graph kind of looks the same. I can't draw very well, but that's what it would